Alrighty, we're in lesson 73, and it is on page 466, and we get to talk about geometry, which is a branch of mathematics that deals with such figures as lines, angles, polygons, circles, and solid objects. One concept from geometry that we practice is congruent figures. Recall that figures are congruent if they have the same shape and size. However, congruent figures may be different. Orientations or positions. For example, all four of these triangles are congruent. So you can see they're all the same size, same length, width, and they're just all facing different ways. So the right angle of, and when you see it has that little triangle like that, it just means triangle, triangle 1. And we're using Roman numerals, so there's Roman numeral 1, 2, 3, and that's what Roman numeral 4 looks like. Because the V is 5, you put 1 before it, that means 4. So the right angle of triangle 1 is at the lower left of the triangle. The other triangles may be reoriented or moved to match triangle 1. To reorient triangle 2, we may turn the triangle so that its right angle is at the lower left. So this triangle, you just swoop it on over, just like this shows, you swoop it on over, and then they're in the same place. To reorient triangle 3, we may flip the triangle as we might flip a pancake or flip a page in a book. Imagine flipping triangle 3 so that the right angle is at the lower left. So if we look back up at triangle 3, we just whoop, and it would be in the same place as triangle 1. And then to reorient triangle 4, we may both turn and flip the triangle. Imagine turning triangle 4 so that it's oriented like triangle 3. After turning the triangle, flip the triangle to match. So we got this one, it's kind of sideways we'd make it go up, and then that was terrible, but we'd make it go up, and then flip over. So that's how you would move it to be the same as triangle 1. And to put each of triangles 2, 3, and 4 in the same location as triangle 1 requires an additional step. Each reoriented triangle needs to slide to the location of triangle 1. So we could still move this, but it's over here. We need to slide it over to triangle 1. This one we could still flip, but we need to slide it over to triangle 1. And this one we'd need to kind of turn and flip and then slide it over to triangle 1. So turns, flips, and slides are 3 ways of moving figures. In geometry, we call these movements transformations, and we give them special names. A turn is a rotation, so if I tell you to turn around, you do a full rotation. A flip is a reflection, so if you think about a flip being kind of like a mirror, that's why it's a reflection. And slide is a translation. So that one I think might be difficult to remember, but a slide, you translate it over. And if you ever forget, hey, there's the key there for you. It tells you that slide is translation, turn is rotation, and flip is reflection. So whenever you have this on future assignments, it is page 468. Alright, let me try and move this to get rid of the glare a little bit. Let's see. Which transformation would move triangle 2 to the same orientation as location 1? So we have triangle triangle 1, and there's its angle that we're trying to move. So this one, we just kind of turn it over on its side. So we are going to, and now the glare someplace else. We're going to kind of turn it and slide, because we gotta turn it and then slide it over to meet that triangle 1. It says we move triangle 2 to location with 2 transformations. A turn, so boop, turn and slide it on over. Then we may turn to around point B, blah, blah, blah. We call a slide a translation and a turn a rotation. So translation, rotation. Rotation, translation. So rotation is turn, translation, slide it on over. All right, and since that's the only example, we're going to kind of do this activity, but we're just going to look at some tuna cans because, gotta stock up. All right, so I'm going to make this one, it's facing forward. This one, still facing forward, but it's not in the same place. So what I need to do is turn, and then I would slide it on over, although I'm gonna stack it. So this would be turn and slide to be in that same place, which is also called a rotation and translation. Now if it was like this and it's upside down, I'd have to flip it back over, which is a reflection, and slide it on over, translation. So again, a flip, I'd have to turn it back over and slide it on over. Now I can have it kind of backwards, and I'd still have to turn, rotation, and slide, translation, it on over. So hopefully that visual kind of helps you guys see it. So here we go. This would be a slider translation. Whoop, putting it in place. This is, a turn or rotation. And this would be a flip. And then slide. So hopefully that visual helps. And let's look at lesson practice real quick. We're just going to do B and C. So this says, which transformations would position triangle ABC on triangle DCE, or DEC, sorry. So here we go, we have triangle ABC. So this triangle here is triangle ABC, and we want to make it right on top of triangle DCE. So we've got to flip it on over. So this, we'd have to, well, if you look at that, it kind of looks like a butterfly, right? And we know that butterflies are symmetrical. They have the same on two sides. So we just, boop, flip it on over. So which transformations would position triangle ABC onto DEC? You just, whoop, flip. Or, I think what they'd want you to do is move it up to, let's see, you would slide it up and then you would flip it. So slide it up, same as translation, and flip it, as I think what they're looking for. Yep. So slide, flip. But you could, I think it's going at C is the thing. So slide, flip. That's how you do that. And it says to use a colored tile model to turn and flip and slide, which is what I did there with the tuna. So hopefully that helped with that. And stay tuned for examples.